क्वालिटी कर दो,
क्या कर दो?
क्वालिटी में
इसमें नहीं, यही है इस समय फ़िलहाल जो है।
तो यहाँ पे दो तरह की पावर की बात हुई थी ना, स्विचिंग एंड,
नहीं
तो
रहने
ये जो स्टैटिक पावर
ठीक है,
डिसिपेशन
जैसे मैं
है, ये
बोल
पावर
दूँ वैसे कर
डिसिपेशन
लीजिए।
कब पॉसिबल है? अगर ये ऑफ ट्रांजिस्टर,
आराम से बैठ के कर
देखो
लो,
ना,
थोड़ी देर में
अभी
वो चार्ज हो
VDD
जाएगा
से
फिर उसमें
ग्राउंड
लगा
कोई
के छोड़
पास
देंगे।
नहीं बन सकता। Is there a possibility? No. ये ऑफ है तो ये ऑन है, दूसरी पोजीशन में ये वाला ऑन था तो नीचे वाला ऑफ था, लेकिन अगर ये ऑफ ट्रांजिस्टर कुछ लीक करता जाएगा, करंट कुछ फ्लो करता जाएगा, तो यहाँ से सीधे पाथ बनेगा, इसी को बोला लीकेज, और यही लीकेज मल्टीप्लाइड बाय VDD इसकी स्टैटिक पावर डिसिपेशन है कि नहीं? और ऐसे जितने होंगे n, वो मल्टीप्लाई कर दो पूरी चिप की स्टैटिक पावर डिसिपेशन।
बेसिकली मैम कि जितना टाइम वो 0 से 1 स्टेट पे जाने के लिए तो एकदम से तो नहीं चला जाएगा।
अभी आप 0 से 1 और 1 से 0 नहीं, 0 पे 1 जहाँ पे स्टेबल है वहाँ की बात करेंगे, उसको बोला स्टैटिक। ये वाला एरिया ना, यहाँ पे कोई चेंज नहीं होगा, और यहाँ पे एक्सेस जो है ये टाइम एक्सेस है। मैं कह रही हूँ यहाँ पे टाइम चेंज होता जा रहा है पर वैल्यू चेंज नहीं है, तो स्टेट तो शांति से बैठा रहेगा, एक स्टेट है, आपने टर्न ऑन कर दिया तो ऑन रहे, ऑफ कर दिया तो ऑफ रहे, ये स्विच का काम होता है। तो ये स्विच यहाँ पे जब लीक करता है तो लीकेज करंट सीधे बनता है VDD से ग्राउंड, और CMOS को तो बनाया ही उससे गया था। CMOS was designed in such a way that it should not happen, but it happens in a small devices. छोटा करते जा रहे हैं ट्रांजिस्टर को।
Ma'am, if off current is the concern in bigger integrated chips, ma'am, are there any ways we can use the off current in a way?
In the sub-threshold region of the graph, it is otherwise used for analog device. You know, there you are getting a gain, basically. We'll come to that also. But when I am talking about digital domain, just understand digital means 0 and 1. 0 and 1 means switching of a transistor. The transistor has a specific state when it is 0, a specific state when it is 1. But in that particular state, it is not working like an ideal switch. इतनी बात, ये बात समझ इस रीजन का कहाँ यूज करेंगे वो भी बात, पर कहने का मतलब ये, if you are working with MOSFETs, you will have to calculate this sub-threshold swing, and the low value of sub-threshold swing will show less leakage. We just directly conclude that. ये conclusion है, physics conclude कर रही है कि ऐसा ट्रांजिस्टर जिसमें सब-थ्रेशोल्ड स्विंग कम होगा ना वो बेटर है, राइट? So यहाँ पे हम बात कर रहे थे what is static when the logic is fixed, what is dynamic when the logic is changing. So the question is logic will change, isn't it? Inside the chip the logic has to change depending on input. So this is the useful power which is used, consumed. You know there are two terms, a power dissipated, कुछ नहीं हो रहा है, dissipate होती जाती है, काम कोई नहीं हो रहा, it is not being converted into work. Power consumed is power which is required to change the logic. So the transition region power is known as dynamic power. It depends on, very important, frequency. How fast are you switching? Frequency, right? In 1 second, how many times we are changing? Which is the clock frequency of a processor. When we go
VLSI. Where it is used in almost nowadays. It is used in almost all of the applications, electronic applications that are around us. For example, if we see our mobile phones, projector, TV screens, or anything that is there, laptops, everywhere there is use of this VLSI field. These are all the topics I am planning to cover. So first is the introduction, where we will know the basics, and then we have the VLSI design flow, basically how the specifications that are there and they are being converted to hardware chips. Then we have the VLSI technologies. For example, here we will get to know that why suppose the Apple phones that we have is more expensive than Android phones. This is one of the case studies which we will study in this VLSI technologies. Then we have EDA tools. Next is the challenges that we face in the industry. Then after that we have applications of the VLSI, and then what is the future that is there for the industry, and the last part is the case study, where we will understand a little bit about these 5 processors. Okay. So let us go one by one. So first is the introduction of it. So as I already told that VLSI stands for very large scale integration. And so what do you mean by very large scale? It is basically we have millions of transistors on a single chip, okay, or more than that. Then we say that it is very large scale integration, and it is basically the base foundation of modern electronics. If I talk about the period of 1960s and 1980s, you will see that if we talk about TV prices during that time and today, you will see that TV prices are getting cheaper and cheaper by days. That is because of the advancement in the electronics that we are seeing. Okay, all the electronics products are getting cheaper and not expensive if we talk in the same range and same specification. And also the size of the electronics, size of these electronic devices is getting smaller and smaller day by day. For example, now the phones that we used in early 2000s, they were not able to do these much functions as nowadays Android phone or an Apple smartphone is capable of performing. So the main reason for that is the technological advancement that comes in the VLSI. So if I talk about today, we have advanced so much in technology in VLSI that we are able to design a single transistor on a 3 nanometer technology mode, which means that the gate length of the transistor is 3 nanometer. So and earlier it was around 180 nanometer. So there is you can think of it like a square box. That now we are able to perform the same functionality of the square box in a 3 nanometer size. And earlier we used to have a 180 nanometer size for the square box. So if I talk about, suppose this is the ballpoint pen. If you think about that dot of pen, okay, see the tip of the pen. So that is around 0.8 mm, and 0.8 mm is this much. 8 lakhs in nanometers. So that means that on a single tip of pen you can have up to 8 lakhs transistors now. And earlier during earlier time it was actually 8 lakh divided by 180. Those many transistors. So the density of the chip is increasing, and we are able to accommodate these many transistors now on 1 by 1 or whatever the size of the die that is there. That is how the technology is advancing. So the latest technology that we are running is 3 nanometer technology, which is used in basically Apple i15 series, i15 Pro series is there. Na? So in that series we are using this 3 nanometer technology, where those many transistors, the density of the transistor is so much that that much high that we are able to accommodate those many functions on.
People may not be aware which processor, right? So what we look for in a better processor? Okay. This is the prime thing that we look for. What's the first thing that comes in our mind when we go to purchase a mobile phone? You will have, Anjali? You are having a range of mobiles nowadays, isn't it? And all having almost similar features. Which one will you choose?
money efficient
Features, range, कौन सी range? Cost,
cost
speed, right? Speed is the first thing that we look for when we go to either purchase a laptop or when we go to purchase any computational device, right? If we want to use that device for computation. इंटरनेट हमें कैसा चाहिए? फास्ट. प्रोसेसिंग हमें कैसी चाहिए? फास्ट. अगर 1 सेकेंड से 2 सेकेंड लग जाए उसको ढूंढते हुए इंटरनेट को, we get puzzled, isn't it? So what is that making things fast? साइज फोन का कैसा होना चाहिए? पॉकेट में आ जाए, वॉलेट में आ जाए, हैवी ना हो, कैरी करने में, बातें करनी होती है तो हाथ उठता है, isn't it? So we want it to be light. What else? Just as an end user, don't think you are aware about the technology. जिसको कुछ नहीं पता वो क्या कहेंगे? यही सब मांगेंगे, कितना तेज चलता है, कितनी कैपेसिटी. तो ये सब कैसे पॉसिबल हो रहा है? Every 6 months you will have a new version of mobile phone. Every 6 months, after every 6 months you will have new laptop with new, you can say, version of your processor, right? i7, i8, i9. Within 6 months or in a year's time, technology change, right? So that is contributed by or revolutionized by nothing but VLSI technology. So that is the power of VLSI, bringing things from micrometers to sub-nanometers. Even if it is not just 1 nanometer, it is sub-nanometer, lower than that. Okay? So just go and check what processor is there in your mobile phone, what processor is there in your laptops, and see the features. Okay? So what we are going to see, okay, now we have seen that your mobile or your laptop carries hundreds of features. Bluetooth भी होगा, कैमरा भी होगा, इंटरनेट कनेक्टिविटी 5G, 6G मोबाइल्स, राइट? प्रोसेसर अलग है, रैम अलग है, ठीक है, और स्टोरेज अलग है. रैम एंड स्टोरेज आर 2 different things I am talking about, ठीक है. और तो इन सब के लिए these can, I mean all these features have different processing. DSP तो सुना होगा सबने, digital signal processing. So different types of processing is required. So that means different ICs or different modules are required to be set in a box, which is your mobile phone ultimately, right? So all these devices individually, they have to communicate, right? When you are using internet, do you want nothing else on your mobile phone? जब इंटरनेट हम एक्सेस कर रहे हो या व्हाट्सएप या कुछ और हम एक्सेस कर रहे हो, क्या हम चाहेंगे कि कॉल ना आए? नहीं ना, हमें कॉल भी चाहिए, मैसेज अगर आ रहा है तो वो भी डिस्प्ले हो जाना चाहिए. Okay, so all these things means they have to be interlinked, right? They should not be independent. So if they are interlinked, what do we want? They should communicate to each other. If you are using Bluetooth and there is a call, there must be some application that can connect, that there is a call and it is displayed while you are using internet or maybe WhatsApp. Okay? So how does these devices communicate to each other? No, I mean there are 2 processors, let us say